Okay, we're going to do some proofs in this video. There's a couple things we need to do just to make sure that we are ready. So let's go ahead and take a look at this upper left corner right here. And this symbol is the congruent symbol. So that symbol says congruent. What congruent means is it's kind of like equals, but it means it's a separate object. So for example, these two basketballs could be congruent. So maybe a basketball company produces a bunch of different basketballs and they're all the exact same size and shape, but they are different basketballs. One goes to house A, one goes to house B, and they're the same type of basketball, but they're actually different physical basketballs. And so we use congruent for this idea. So that'll come into play when we're talking about angles that are two different angles, but they're the same size, or maybe triangles or squares or anything like that. Okay, let's go ahead and come down here. Here we're just going to introduce the symbol for angle. So for a shorthand for writing angle, we can either use this little symbol or basically the same thing with a little ring on it. We can use either of those for angle, just for a little bit of shorthand here. Okay, let's go ahead and come check out one of these lines. And so if I was going to start at a point, that's a really big point. Let's see, if I'm going to start at a point and go all the way around in a full circle, well, that's going to be 360 degrees. So all the way around in a full circle is 360 degrees. So what if I were to just do half of that? Well, if I were to do half of that, then that would be 180 degrees. And so it's really important that we know that a straight line is going to be 180 degrees, whereas a circle, a full circle, is going to be 360 degrees. Here is our general triangle sum theorem. So in general, angle 1 plus angle 2 plus angle 3 is going to equal to 180 degrees. Here's another example. So here's a specific example on the right-hand side. So if I have, three different angles over here and I were to add them all up, so 60 plus 40 is 100 plus another 80 is 180. So this is just a specific example, but obviously those angles could be anything like any angle 1, angle 2, and angle 3, and they're always going to add up to 180. So we're going to go through a proof of this triangle sum theorem. So rather than just saying, angle 1, 2, and 3 add up to 180 because I told you so, or because the math book told you so, we're going to go through exactly why. We're going to show you a proof of it. So what I did is I took a triangle and I kind of extended the bottom here to make a nice long straight line. And through that top point, I'm going to draw a parallel line. So I can go ahead and mark it with arrows here. So I'm going to put an arrow there and an arrow there. And that shows that those two lines are parallel. So we have some parallel lines here. And when I draw that top parallel line, it creates a couple of new angles. So I'm just going to label those, maybe angle 4 and angle 5. And let's think about what I can do with this information. So when I look at this top line right here, and I look at angle 4, angle 3, and angle 5, well, it looks like angle 4, angle 3, and angle 5 form that straight line. So, well, if they form a straight line, well, then what do I know about angle 4 added to angle 3 added to angle 5? Well, if they form a straight line, well, I know that they're going to add up to 180 degrees. And so I might say, okay, well, angle 4 plus angle 3 plus angle 5 equals 180 degrees. And I'm going to give it a little reason here. So what's my reason? Well, they are angles on a line. And angles, any set of angles on a straight line is going to add up to 180. So that's kind of why I know that. All right, so what else can I do from here? Well, let's take a look. I kind of added in those angles 4 and 5 at the very beginning. What I really want to include in the end to get to the triangle sum theorem is angle 1 and angle 2. Well, let's think about angle 1. How would angle 1 compare to angle 4? Well, angle 1 and angle 4 are alternate interior angles because if I'm thinking of these parallel lines, cut by this transversal here, and I might even extend that transversal so we can see. So here's my transversal on this green line that can be extended, and then this line here that could be extended. So I have parallel lines cut by a transversal, and then angle 1 and angle 4 are alternate interior angles. Well, what do we know about alternate interior angles? They're congruent. So I know that angle 1 is the same or is congruent to angle 4. And then what's the other angle I wanted to include? I also wanted to say something about angle 2. Well, what do I know about angle 2? Well, angle 2 and angle 5 are also alternate interior angles. And so again, I'm going to be looking at these parallel lines, so the bottom line and the top line. And then this time, I'm going to be looking at this line as a transversal right here. So here's my transversal. And then I can see that angle 2 and angle 5 are alternate interior angles. So then I'm going to say, okay, well, I also know that angle 2 is congruent to angle 5. Okay, what's a good reason for that? How could I say that 1 and 4 are the same and 2 and 5 are the same? Well, that's going to be alternate interior angles. So alternate interior angles are congruent. So that's how I know that 1 and 4 are the same and 2 and 5 are the same. Okay. Okay, so next, I'm going to go ahead and kind of combine these two ideas. So I'm essentially kind of going to rewrite that first step here. So that first step says 4 plus 3 plus 5 equals 180. So let me just kind of start with the end here. So I have equals 180. And I know that that angle 3 is inside the triangle. So I kind of like that angle 3 because I'm thinking of where I want to go to in the end. I want to end up with 1 plus 2 plus 3 equals 180 because that's the triangle sum theorem that I'm trying to prove. Now, let's think about what I could do with, say, this angle 4. Okay, so what could I maybe replace angle 4 with? What do I know about angle 4? Well, I know that angle 4 is the same as angle 1. So if angle 4 and angle 1 are exactly the same, well, could I just write angle 1 instead of angle 4? Sure. Okay. Okay, let's go ahead and do the same thing again. So now I'm at angle 1 instead of 4, plus 3, plus angle 5. Well, what could I replace angle 5 with? What do we know about angle 5? Well, angle 5 is the same thing as angle 2. So if angle 5 and angle 2 are exactly the same, then I could just go ahead and put, instead of plus angle 5, I could write plus angle 2. Okay, and let's think about what I did there. So, well, I replaced angle 4 with angle 1, and I replaced angle 5 with angle 2. And kind of a mathier word for replacing is substituting. So what I did is I substituted an equivalent angle in. So you might think, in a regular traditional classroom, if your teacher is not there, then they're replaced with a substitute teacher. And so if I want to replace something equivalent, we can call that substitution. And now I'm done. Well, why am I done? Because my last step here says that angle 1 plus angle 3 plus angle 2 is equal to 180. And where is angle 1, 2, and 3? Well, angle 1, 2, and 3 are all inside the triangle. So that means that angle 1 plus angle 2 plus angle 3 equals 180. So what did I just show? The triangle sum theorem, and I just proved it. Here's the vertical angles theorem. And vertical angles, or you might think of opposite angles, are congruent. So if I'm thinking in this left picture here, this is kind of the general. So if I think of angle 1 and angle 3, those are opposite each other. And so angle 1 and angle 3 are going to be the same. And if I think of angle 2, well, what's opposite angle 2? Angle 4. And so angle 2 and angle 4 are going to be the same. Similarly, here's just an example with exact numbers. So here, 80 and 80 opposite each other are going to be the same, and 100 and 100 are opposite each other. They're going to be the same as well. You might think of scissors as kind of an example. So think as you open and close scissors, the opposite angles are getting either bigger and smaller together. So let's go ahead and prove this vertical angles theorem. So let's just kind of think of an example here, and let's maybe think about angles 1 and 2. And what's true about angles 1 and 2? Well, angles 1 and 2 are on a straight line. And a straight line is going to add up to 180 degrees. So if 1 and 2 are on a straight line, then I know that angle 1 plus angle 2 will equal to 180. And by the same idea, if I thought of angle 1 and angle 4, well, angle 1 and angle 4 are also on a straight line. So I could say that angle 1 plus angle 4 is also equal to 180 degrees. So I'm going to write that as well. So we also know that angle 1 plus angle 4 is also equal to 180 degrees. Okay, now how do we know that? Well, 1 and 2 are on a straight line, so I could say angles on a straight line. Okay, and so another kind of a mathier way to say a pair of angles on a straight line is to say a linear pair. And so these are a pair of angles that are on a line. So a pair of angles on a line we can say is a linear pair or a linear pair. So now let's go ahead and take a look at what we have. So we have 1 plus 2 is 180, and 1 plus 4 is 180. So I'm going to go down to the next step, and I'm going to kind of just start copying this step here. So I'm going to say, okay, well, angle 1 plus angle 2 is equal to 180. But instead of writing that 180, I'm going to think about if I can replace the 180 with something else that's also equivalent to it. So let's take a look at what I have here. Well, here I have 180 written right here. And what is equivalent to 180? Well, something equivalent to 180 is angle 1 plus angle 4. So instead of writing this 180 right here, I'm going to write something that's equivalent to it. Well, angle 1 plus angle 4 is something that's equivalent to it. And what's a good reason for that? So I just replaced something equivalent, or I used substitution. So I used, let's see if I can get it here. I'm having trouble. Okay, let's see here. So I used substitution. Oops. Let's get the right one here. There we go. Kind of. Okay, it doesn't want to do it. I got it though. All right, so I used substitution. Okay. So by substitution, I could say that, well, instead of 180 degrees, what's equivalent to 180 degrees? Angle 1 plus angle 4. All right, and we're actually quite close. This is a short proof. So when I look at both the left side and the right side, I see that they both have an angle 1. So I'm just going to subtract an angle 1 from both sides. So if I subtract an angle 1 from the left side, I have angle 2. When I subtract an angle 1 from the right side, I have angle 4. And so what I'm left with is that angle 2 and angle 4 are equivalent. Now, what did I do to get from kind of the last step or the step previous to the very last step? I subtracted. So I'm just going to say that my reason is subtraction. Okay? And what do we have here? What's our end result? I am ending with angle 2 and angle 4 are the same. Well, what are angle 2 and angle 4? Well, they're vertical angles. So what I did is I just proved the vertical angles theorem. The last theorem we're going to talk about is alternate interior angles. Okay, so let's address the interior first. So interior means inside. So 3, 5, 6, and 4 are all inside or interior to these two lines. Okay. Next, alternate. Alternate kind of means opposite. So I want interior, inside angles that are alternate or opposite sides. So for example, angle 3 and angle 6 are alternate sides of the transversal, opposite sides of the transversal, and they're interior. So the alternate interior angles theorem says that angle 3 is congruent to angle 6. Similarly, angle 4 and angle 5 are both alternate sides of the transversal, and interior, they are inside the two lines. So angle 4 is congruent to angle 5. Our last proof, we're going to prove the alternate interior angles theorem. So to prove this, I just need to choose a pair of alternate interior angles to prove congruent. I could either choose pair 3 and 6 or pair 4 and 5. I'm just going to pick one of the pairs kind of arbitrarily. So let's just choose to prove angle 3 and 6. So that's kind of our end goal, is to prove that they're the same. To start this proof off, I'm going to try and find some linear pairs to work with. So if I look at angle 1 and angle 3, angle 1 plus angle 3 is going to equal to 180 because they are a linear pair. So angle 1 plus angle 3 is equal to 180 because they're a pair on a line, or a linear pair. And similarly, if I look at 5 and 6, well, 5 and 6 are also on a line. They're also a pair on a line, and a line is 180 degrees. So I can also say that angle 5 plus angle 6 is equal to 180. And what's kind of my reasoning behind that? Well, these are each linear pairs. So I'm going to write that they are linear pairs, and that's kind of why I can say that they add up to 180. Okay, for my next step, let's go ahead and kind of start off by rewriting that first step. So angle 1 plus angle 3 is equal to 180. But instead of writing that 180, I'm going to see if I can replace it with something. So what is equivalent to the 180? Well, something equivalent to 180 is angle 5 plus angle 6. So I'm going to come down here and say, well, instead of 180, I'm going to replace it with something that's equivalent to it. So how about angle 5 plus angle 6? Okay, what did I do? I replaced it. So I put something that's equivalent to it. So I substituted it. So my reason could be substitution right here. The next thing I'm going to take a look at is angle 1 and angle 5. Now angle 1 and angle 5 we could say are both in the upper left corner. So they're both in the upper left corner. So that means they are corresponding angles. And what's true about corresponding angles? Well, corresponding angles are congruent. So what that means is angle 1 and angle 5 are going to be the same. So what I can do is where I see an angle 1, I can replace it with an angle 5. So now I have, instead of angle 1, again, I'm just kind of rewriting that previous step there, but instead of angle 1, I'm going to write angle 5 because 1 and 5 are corresponding angles, therefore they're congruent or equivalent. Okay, let's go ahead and write out the rest of this. So angle 5 instead of 1 plus angle 3 is equal to angle 5 plus angle 6. Well, what kind of reasoning did I use there? Well, I used corresponding angles. And also, I just substituted angle 5 in for angle 1. And how come I could substitute those? Because corresponding angles are congruent. So I kind of used two reasons there. Okay. All right, so we are very close. Now when I look at the left side and the right side, I notice that I have an angle 5 on both. So what would happen here if I just subtracted angle 5 on both sides? So if I just subtract angle 5 on both sides, let's see what we have left. So now I just have an angle 3 on the left side and an angle 6 on the right side. And wait a second, isn't that what I was trying to prove? That angle 3 and angle 6 are congruent because angle 3 and angle 6 are alternate interior angles. Okay, and how did I get there? What did I do for that last step? Well, I used subtraction. So by subtracting the angle 5, I've shown that angle 3 and angle 6 are congruent, and angle 3 and angle 6 are alternate interior angles, so I've completed this proof.